Hey, hi everyone, welcome back to the channel. This is Unsi Reddy. Today in this video we are going to do one of the project on ML algorithms like machine learning algorithm. So the project title is simple, we can say breakfast sales and customer engagement. So it is a Kaggle project. I collect from the data from the Kaggle. So it's uploaded on I think so 1 month ago. Just 1 month ago it has uploaded. So the details of this the like data set, the details of the data set as so it is one of the hometown data set like Surat Breakfast Center. So in that data center, he collects the data set from the here data analyst, data science, some of the things. So this coming to the columns present in this data set, like data is collected from October to November, just October, November, and dishes name is different dishes are available in the shop. Prices are also as per the plate they required. They they mentioned that dining they ate in like dining means someone are eating in the shop and someone are taking parcels to the home. Total customers are individual dishes for the per day. So it shows that here total customer column denotes a total customer for the individual dish for the day. So it shows like that. And total sales for a day of a dish. So here they give the sales of a dish. So for that, let me including some libraries which we are required. Okay, like I am using Python libraries. Okay, import numpy as np, import pandas as pd, import matplotlib dot pyplot as pld. I am importing next to I am importing one of the model, another model like import plot plotty plotty dot express as xp. Okay, let's execute. If you find any errors, let me try to install any packages. I think so package installation, right. So I got a package installation. Let me show you how to install the package also. So here the package I find no module name is. Let's copy this and paste over. Let me see what are the which package is it belongs to. So it belongs to partly 3.0 package only. So I find the error. Next I copy this thing and how to install Plotly in Conda. Like I'm installing let me understand in Jupyter. Okay, how to install the Plotly in Jupyter. I got this tutorial. Let me open this thing. Oh, I think so my net is too lag today. Let me open these things. So I found this. Yeah, this is the thing I found here. So let's go for the Jupyter, and I'm doing one more statement line. Sorry, I'm adding one more column here. Pip, I copy the thing. Let me execute. Is there any? It will take some time to execute these things. Let me wait for that. So it is a Python visualization using package. So it is used to visualize the data which is present in the. So it is very helpful thing also. Let me wait how much time it's required to execute like install process. So I think so it's taking too much of time to execute, so let me wait for that. Yeah, it's completely executed. Let me run this. If no, so I didn't find any error here. So now I'm loading the data. Load the data. Okay, further I'm storing that here. Df equals to pd dot read csv. I'm loading the read csv file. The name of the file is restaurant underscore data dot csv. Let's execute this. I didn't find any error. Let's read the data of tf dot date. So as we discussed, like here the date, dish name, price, deny, parcel, total customers, and total sales. These are the things. So per day, here 10/1/2023, like the 10th month starting first day. Terpaha 20, price is 20, and same samosa 12, price is 12, 10 members, and parcel 12 members, total customer 22 members. So the cost will be sale of 264. So we get this thing. Let's see df dot tail last 10 things. This is the last thing, 10 things we have. Let's read what are the rows and columns. So it contained nearly 649 rows and 7 columns. uh, this data set content. Okay, let me find the like what you decide like let me find the list of dishes name. Let me find the list of dishes name. For that I'm taking the column, which column, like dishes name dot dishes name dot unique. I'm finding the unique things, like it will execute the unique things what which I have present. So these are the dishes types. Overall 695. We have 1 2 3 4 5 6 dishes we have. So we have dishes in it. Let me find more information about information. So these are the types, like date is a object, dishes name is object, remaining everything are in the 64 things. So we get a depth inset, like what information we have. So let me find, is there any null values. Finding null values. Df dot is nan dot sum. So I'm So I found there is no null values, so this data set is very well. We don't need to add any missing values, we don't need to make any outliers, anything we don't want to, right? It's absolutely fine. Okay, let me plot, like plot the like plot the like I'm using scatter plot, scatter plot to find price and price and total sales, like how much of the things present, total sales. Okay, further fig equals to fig x dot scatter, I'm passing the data set name, and x-axis I'm taking price, like that is y-axis, y equals to, like I am y-axis I'm taking TOTA, total sales. Here color equals to, let me, color need to be like highlighting things, price, I'm highlighting the price. That's it. Okay, let's execute this. If we find any error, no, fig. Yeah, have a look. So here for the total prices and total sales, on x-axis we take in prices and y-axis we take a total sales. So here there is a total sales in the price list of 0 to 15 members, there is approximately 750, right? So like that only 15 to 20, in the price list of 20 there is nearly 1600 prices, like sales are going for the 20 rupees price, remaining for 30 rupees they have 220 2250 sales for 30 rupees cost. So this is the how we predict the like finding the scatter based on the prices and total scale. Okay, next, like that only we can go for customers and sales. Okay, plot for total customers and total sales. Okay, same thing, and copy this thing, paste to over, and figure one, find scatter plot, and x-axis I go for total customers, and y-axis I go for this sales, and I am going for color light, uh, I'm going for the color as a price. Okay, based on the price I need to execute, like fig 1, I'm executing the fig 1. Yeah, this is things I got from the customers and total scales. So around 50 customers, total like total 40 customers, we get total size 480 and the price is 12 rupees. So same like that here, total customers is 57 numbers, total sales they made is 1710 rupees and the price list is 30. So this is how a simple graph look like. Okay, and next we go for the building the model things. Okay, I'm storing df equals to df dot drop, I'm dropping the data. So date, I don't require any data column because we are going for simple thing. Axis equals to 1, axis is equals to 1. So now df dot head, let me see the df dot head. So we don't have any date column, right? Simply I can write here drop drop in the date column. Okay, now we need to do some label encoding for the data, so splitting the things. For that, from sklearn dot preprocessing preprocessing import label label encoder. Execute this. If you find there is no error, so I'm saying that label encode equals to, I'm building a model like encoder, so each and everything has 12. Okay, next we are going to divide like with dishes name. So we need to like, this is a categorical features, so we need to divide these categorical features. That's why we use the label encoder. I need to do for the dishes. Okay, df dot dish names, like dish name equals to, and like I'm doing the label encoder here only. Label encode, like label encode dot fit transformation, and transforming the data into transform fit transform df dish name. It execute. Now let me see the df dot head, what we get. So see, the label we have assigned the ranking for these things, so 5 4 3 like that, so each and everything has converted into numerical data. Now we can able to ping, like now we can able to like build a model. For building a model we are using linear regression, and also another more algorithm, okay, like random forest. From sklearn dot model selection, I'm importing try test splitter. Okay, for splitting the data into x and y, like x data independent dependent variable. From sklearn dot linear underscore model, linear underscore model input linear regression. So I'm inputting linear regression like that only. I'm like including it for the mathematical calculations. I need like a sklearn dot matrix, so some to evaluate the outputs of the algorithm. Input mean absolute error, I'm putting mean absolute error, absolute error comma r2 square, r2 square. These two things I'm going to implement. Okay, now I'm storing x equals to df dot drop. I'm storing the all, dividing the independent and dependent variables. Here sales is a dependent variable, here sales is a dependent variable. I am separating this thing, total sales. Okay, I'm dropping, and x equals to 1, same as I'm storing the y df dot, I'm taking the dependence as a table load sales. Let's find head, x dot head. So in h We get a dishes name, price, the name, parcel, total customer. Like that, y dot head, we get sales. So this is the we have divided things. Okay, now we need to split the extra and y train data. Extra, comma, like extra x test, y train, comma, y test equals to train underscore test underscore split, and splitting and passing the x data, y data, and test size. I'm taking this test size equals to 20, like 20 means 2.0, and random state equals to 30. Okay, let's execute. Oh, I get a error where here the time is 2. Okay, that's fine. 2.0 is not mentioned, like 0.2. Now invalid syntax. Oh, sorry. 2.0. Again, random state equals to 30. Yeah, now fine. I think let's see the head of string dot head. So this is data is converted randomly, and xtest dot head. So this is like that, y train dot head, y train dot head, like that, y test dot head. So these are the things we have later, right? So now we are going to build a model. Okay, now we are going to build a model. For that, like here, linear regression, linear regression. For that, I am storing rig equals to linear regression. Now regression dot, I am fitting the data x train, x train, y underscore y train. So I'm fitting the data x train and y train. Fine. Let's execute. Yeah, data model has fitted. Linear regression model has fitted. Now I'm going to predict the values. Predict equals to rig dot predicting the outputs data. Prediction of x test. Based on the x test only, I need to put the data and print y underscore predict. So the output result is this. We have predicting the output result of our model. So this is the things we have done. Okay, now we are going to install another algorithm, that is random forest. Random forest. Okay. For that case, we need to, like random forest. Initially, we need to like we need to do the one of the installation of random forest, like from sklearn, from sklearn.tree import random for est forest regression. That is, yeah, I find an error. So I didn't find a model like random forest regression from the regression from the things. So I think so, and I find error regression is not perfect. I think regressor. I think regressor. No, now also it's not showing. So and trees not. Let me test in ensemble. So yeah, it's an ensemble. Now also the model name is not recognized. Somewhere I'm making a mistake. Okay, exactly. I think yeah. Now it's fine. Sorry, I make a like forest equals to random forest regressor. I'm inserting this now forest dot fit next line white line fine y underscore predict one equals to for est forest dot predict x test and clicking x test. Now print y underscore prid 1. So look how the differences is between this linear regression and random forest. So first value we get 1055.277. So for the random forest we get 1019. How the model is predicted. So let me see what exactly that score. How much score does linear regression and random forest has show us. Okay, let's see that scores. For linear, like linear regression, for linear regression, R2 underscore is what score. I'm passing y underscore test and y underscore newly predicted. Okay, and now I am print linear regression. So it's gives 0.96196 percentage. Let me see for random forest. So regressor equals to R2 underscore score. I'm pausing y underscore test comma y underscore predict 1. Now execute random forest regressor. It gives 99%, that is 0.9 means 99%. So how the models we compare, like linear regression is more than like not more than these random forest. By this project we have understand that random regression, like random forest regression is work well when you compare to the linear regression. So I hope you are all like this video. Please like, share and subscribe for more updates. Thank you friends. Bye bye.